Okay, so now that we've kind of done that practice where it's like, what is going on here, I'm going to try to break down a little bit of the math. So first we have this thing called the objective function, and that's the thing that we're trying to maximize in our problem, but sometimes you're going to be asked to minimize that function. The rules that we created about like the number of labor hours and the number of pounds of clay that we could use every day, those are called constraints. And the constraints usually tell you something that you have to limit. So in our case, we had only 40 hours of labor every day. So we had to create an inequality to say for every bowl and mug, they take a certain amount of time, you only have 40 hours in a day. Similarly, we have to limit the number of pounds of clay to 120. Here's the weird thing. We didn't say anything about this, but clearly you can't make a negative number of bowls. And you can't make a negative number of mugs either. So that means that we have to have these two other inequalities that say b is greater than or equal to 0, m is greater than or equal to 0. So I'm going to take these inequalities that we created, and I'm going to rewrite them with x's and y's because I'm more comfortable graphing with x's and y's. So I have x plus 2y is less than or equal to 40. I have 4x plus 3y is less than or equal to 120. And then I have x is greater than or equal to 0. And I have y is greater than or equal to 0. Notice that I just chose b is x and m is y. It doesn't matter which one you choose, it'll end up giving you the same answer. Just make sure you're the same the whole problem. Our profit function is now 40x plus 50y. Okay, so now our step is, okay, we need to graph these inequalities. And so I'm going to rewrite them as y equals mx plus b inequalities, these two of them. So this would give me, if I subtract x from both sides, I get 2y is less than or equal to 40 minus x. Divide both sides by 2, and I get y is less than or equal to 20 minus 1/2 x. The other one is, I'm going to subtract 4x, and I get 3y is less than or equal to 120 minus 4x. Divide both sides by 3, and I get y is less than or equal to 40 minus 4/3 x. Now I'm going to graph these inequalities. These are both or equal to inequalities, so I can use solid lines. So I'm going to start with 20 minus 1/2 x. And that's going to do like that. I'm just going to fix that a little bit. There we go. And then the other one is 40 minus 4/3 x. That'll look like that. So then my shading, remember that I have these two also. So I'll have that non-negativity on the x and the non-negativity on the y. So my feasible region is the area in between all of these inequalities, which is this stuff that I'm highlighting now. So then the next step here is to figure out these intersections of the vertices of the feasible region. I wrote them out already. Normally you would have to calculate them, but for our purposes, I'm just going to kind of try to give them to you so that you actually are finding ways to apply this information without having to do too much of the like nitty-gritty calculation. Basically what we do is we take these points and we put them in to our objective function. So, for example, 40 times 0 plus 50 times 0 is 0. That's not such a good profit, right? So then the next one we would do is 30 would be 40 times 30 plus 50 times 0, which is 1200. We would have 40 times 24 plus 50 times 8, which is 1360. And then the last one is 40 times 0 plus 50 times 20, which is 1000. And so clearly we can see our maximum value is 1360, and that means that this is x is 24, y is 28. Remember, x's were bowls, y's were mugs. So this says make 24 bowls and 8 mugs, and you'll make the maximum profit of $1,360. Here are sort of the general steps for solving one of these linear programming problems. First, you need to write those inequalities that describe the constraints on the problem. I like to assign variables x's and y's because I'm more comfortable with them, but if you want to stay with, for example, the b and the m, and just remember which axis is the b axis and which axis is the m axis, that just feels kind of confusing to me. I like the x's and y's. You need to write an equation for the objective function to explain how you're going to evaluate what vertex gives you the best answer. Then you need to graph the inequalities and make sure that you're including those non-negativity constraints just in case it doesn't make sense in your problem to like have a negative number of certain things. Test the vertices of the feasible region in the objective function. So put in those values for x and y into your equation. And that's what we just did on the previous slide. And then we just need to interpret the answer in the context of the problem. And that's what we just did at the very end of that last slide. You do have just a couple practice problems in Google Classroom from the textbook, and then you have a mastery check at the very end of the day. So get those things done, and then you're done for the day.